Okay, so first of all, I will give you a brief introduction about Scapy. So, Scapy is a Python program, and it runs on Python interface. Okay, and it is used for network capturing from your network interface card. So, basically, it is a packet analyzer. It captures packet or program. It also craft packets like creating a packet. Okay, so I will do two three things. First, I will try to show how to sniff a packet, and let's see what we can do more. Okay, so first of all, I will tell you, like, if you haven't installed, so what is the way to install it. So you have to first check that your repos, or you are up to date or not, your system is up to date or not. Okay, so in this way you can run it, and then to install it you can write pip3 install Scapy. So in this way you can install. As I have already installed, so I'm not going further into this. So after that, okay, so if I want to sniff a packet, so I have to give some root privileges. So I will give sudo Scapy, Scapy, and it's open. So as you can see over here also, it is Python shell instead. Okay, so I can also run Python commands over here also, like os.system clear. Okay, and let's do our first task, which is to sniff a packet. Sniff packets. Okay, so how to do that? First, there is a command called sniff, simple sniff, and then we have to write, like, what are the other things, what are the other features that you want to add into a particular packet while catching it. So let's say I just want to count only 4 packets. Okay, so this will be the command, and also I can also provide, like, what filters, like filters, filter equivalent to, say, I only want to collect TCP packets, so I will give this command, and this will capture 4 packets with filter TCP from my main interface. Okay, okay, I think it will run when I'll reload this. Okay, I guess this will get some TCP packets over here. And next, if I want to check the summary of that packets that has been already sniffed, so I can create a variable, say a, and then a dot summary. This will give the summary of the packets that I have collected. As you can see that all the packets have the layer TCP in here. None of them are having any different protocols. Okay, so let me explain this first one. Okay, so first is the Ethernet layer of that particular packet, and then the IP layer. Okay, and then there is a TCP layer. Okay, which is to send from this IP to this IP, I guess, and this is the application layer protocol, HTTPS, and there is some raw data. Okay, okay, so for example, if you want to check, um, let's say, what will be the detail of that particular, let's say for the first one, if you want to check, I don't know if it will work or not. If you want to check the detail of that first packet, let's say this one, we can, or we might run this one. Yeah, it will work. So from this I can say that actually all of the data is being collected in a list format, and we can automatically check for, like, if I want to check for the details of this packet, I can run this command with index 0 for this one, we can run index 1, 2 and 3, etc. Okay, so for this, as we said, it will give the details of every particular layer. Okay, so you can see Ethernet is from destination DST with MAC address this one to the source, which is uh, having MAC address this one, and what type of IP it is using. It is IPv4. You can also verify it is using IPv4 with version 4 over here written. Okay, so this or the other further details like top of the stack, length and ID, etc. Okay, so what kind of TCP it is using, protocol, what kind of protocol it is using, or it is written over here. Once again, it is giving the IP address, source IP address and the destination IP address over here. And then you can also see the TCP layer, which is like using source port this, and destination port is HTTPS, sequence number and acknowledgement and other details, flags and etc. You can also see the raw. So raw data is consisting of the actual data written in a hexadecimal format. Okay, so this is the brief details of a particular IP packet, sorry, just a packet. Okay, now let's see one more things that I. So once again, I'm clearing the screen. Okay, okay, now first of all, let's say okay, I will show how to read the pcaps first. Okay, I'll tell you details about pcaps. So I will write the command over here, sudo wireshark So I'm assuming that this command will also give the command to the terminal to open the wireshark with root privileges. So if I'll run it, yeah, it is working well. And you can see these are the filters. Okay, we can also capture it via filter. And can I zoom it in some way? Okay, so let's say first of all, let's capture some of the data. Okay, I'm running and collecting. So I will once again go Facebook, and then I'll search Insta, something like this. And I think we have received ample of packets over here. Okay, so now I will stop it, and the data of collecting all these packets, I will store it in a pcap file. And for that, I will save it in my root directory and say example. Okay, and here I am changing to pcap, not pcap and pncap. So yeah, I'll save it. Example.pcap is saved, and then I'm closing for a while. Okay, process has been terminated. let's see if you got any root on home. I'll check. Okay, I think we got it, but okay, now we will run that pcap, how to check it. So for that, I will create a variable p, and we will do read pcap. So rd pcap, and we will give the address of that particular uh, pcap file. So what was that? Once again, I have to check it. Not in this way. I'll create a new tab, and then I'll write sudo wireshark. Okay, so it is root example.pcap. Okay, now it was root, then example dot pcap. I think that's it. And then I'll close the parenthesis, and yeah, we got it. And now we can see what is inside p. So we can see there are total 5 TCPs packets and 619 UDP packets. We didn't receive any ICMP packets, or we other packets are 16. Okay, we can also check like length of that packet, length of p. So it is receiving, we are receiving 640, which means like 5 plus 169 119 plus 16 is equals to 640. Okay, okay, let us give a particular, so we know that the length of the packets, length of this variable p is 640. So we can create a variable, say pkt, and then once again we can give an index. So it must be, obviously must be like smaller than 640. For example, if I gave value like 640, actually I might receive an error, yeah, because index is out of range. Okay, and if I create packet called p and taking index of say 300, I'll receive a packet. Okay, so it will create, it will have a value dot summary, or if I will write pkt only, I may receive the complete packet. Okay, so you can see that the packet is being taken, and what is the values, like it is giving the ether value up till here. This contains the details of ether, and then this is the IP values. Okay, up till here, and then it is a UDP, it is using UDP as transfer layer, and then it is consisting of raw data. This is the raw data. Okay, raw data is our actual data, okay, that we want to check. Mostly uh, it is being used for this, capturing the raw data itself. Okay, now I can also check the type of that packet. So I can write type and pkt, it will give me the details about. So it is Scapy and layer is L2 Ethernet. Okay, okay, now once again I'm clearing time by time so that I can explain well what I have learned. Okay, now we can also like check the hexadecimal value. So for that I will run hex dump. All of these feature functions have been explained in their actual site, which is scapy.org, I guess, or .com, I don't know, you can check it. And we will return, it will return all the hexadecimal values of all the data it has been collected. It is actually the raw data that has been collected. The complete file shows the raw data into that particular packet pkt. Okay, now, okay, once again we can also check say ls, and once again giving pkt over here. So it will give the details like destination, what is the destination. Okay, MAC field, and this is the MAC address. We didn't specify any other features, and actually there doesn't consist of any other features into this. This is why it is showing none over here. And the source, so this is the MAC address of source once again. So actually this further elaborates other kind of details, but it is, once again I will say that it is a method of getting a more elaborative way about what kind of packet is being sent. Okay, so in this way we can also manipulate and check the data which is being transferred, okay, and stored in a particular pcap file. Okay, so now I will show you how to create a packet. So it is really very easy. So I can just create a packet like this. This packet has been created. Actually this is a packet which consists of only IP layer, and that's it. So once again, for example, I want to create a bit bigger packet, so I will write this must consist of ether also. ether layer and then IP layer and then say UDP this time, UDP layer, and it will create a packet of this. Okay, let's give a variable for this packet so that we can also use it further go. And let's say give a message, say hello. So this packet has been created with the raw. Okay, actually in that packets that we saw earlier, so that raw comprises of the message that is being sent from this packet. So actually this is the message that I want to send from this particular packet. So in this way I will write it, and then if I want to share you the details, I can once again type this a.show, and you can see that raw is equivalent to hello this time. Okay, so actually you can see that source and the destination address is the same. Actually this will also work, like I'm sending from the particular source and receiving from that particular source itself, it will work fine. Okay, it's like a U-turn, some kind of U-turn kind of thing. Okay, and it is a UDP layer, so you can see all the details about that particular packet that I have created. And then if I want to send it, so I will simply say send, and then what was the variable of that packet? A. Okay, so A. So it is saying that MAC address to reach destination not found using broadcast. So it will share. Actually I didn't specify any MAC address, so it is sharing the packet using broadcast. Okay, so for example, if I want to check this same particular packet in Wireshark, I think I can see it, and in loopback it will receive. Okay, once again if I'll send, say send A, I think yeah, I got one packet, and it is using the broadcast, as I specified over here that it is using broadcast because I didn't specify any MAC address over here, destination. Okay, and you can also see over here what is the details of that particular packet. Say um, yeah, you can see the packet is transferring the data, say hello over here. Okay, and this is the hexadecimal format and how the packet is being completely sent. This actually is the whole hexadecimal code for that whole packet. That's why it is showing some gibberish in the following, and then followed by hello, that is the raw message that I'm sending. Okay, it is showing malformed packet because I didn't specify a lot of things, like it is also a broadcast and source is not defined. Okay, so in this way, so I can also create a for loop for say equal to for I in range say let's 5. I want to say send 5 packets, so this will be the function send A. Okay, I will stop it and I will start it once again, continue without saving, and let's see whether it will work or not. Okay, indentation error. Okay, this is not a base like not a problem. Actually I have to specify an indentation, and then I have to give the command. Okay, you can see all the packets has been sent, and once again I have not specified any MAC address, that's why it is broadcasting, and all of the data that we have broadcast is actually all of the packets that we have sent is actually broadcasted. Okay, and since we have transferred the same packet, that's why we are receiving. Okay, I have to first stop it because we are getting some other packets also. Okay, that's why I'm stopping it. So all the length of the packets we are receiving is 61. Okay, why are we receiving 61 packet length? So sorry, I was writing over here. So Yeah, why are we receiving length of 61? So I will show you. So over here, TTL, no, not TTL, it is for the time, it is related to time. Actually the length of this complete packet is 61, size of this complete packet is 61, that's why. And we were looping back to send the same packet, that's why we got 5 packets with length 61, and all the details are actually same. We are not receiving any we are not sending any different packet. Okay, we can also like give a much more complex um, problem. Let's say once again stop it. No, I'll go into loop back once again, but first of all let me write one command. So this will be, I don't know, I'm writing for the first time, and let's see what will happen. I is equals to in range 5 5, and then in order to not broadcast it, I will not use Ethernet this time in while creating a packet. So for this, a equivalent to uh, a will be the packet. Okay, I will write IP, which will comprise of DST. So I will not write D destination, I guess. I will write only source src, and we'll give different f. I don't know whether it will work or not. 127.0.0 dot I over here, so that it will check from, like, the value of I will be 1 in the first a value of I will be equivalent to 0, so I have to add one more thing over here, plus 1. Okay, so first it will receive the packet from source called with IP 127.0.0.1. okay, and then it will, in the next loop, it will receive the data from 0.0.2, etc. Okay, I'm assuming that it will work in this way, but I don't know whether it will work or not in this way, or it will raise an error or not. I'm just checking it. ICMP, so I'm taking ICMP protocol this time, which is Internet Control Message Protocol, and I will also send a message, say once again hello. Okay, and then once again giving an indentation, and then I will send this, not in this way, send a. I don't know, maybe it will work. I actually think that it must work in this way. Okay, and I'm opening this, not applying any filter, and then let's run it. Okay, yes, now yeah, it is actually working. Like you can see, the first sources we are receiving from the same destination, which is ours destination. Okay, and then we are receiving a packet from this IP address. You can see this is Internet Control Message Protocol, and this IP address once again, and in this way we are transferring the data. And we can also check from Wireshark also, like what kind of data is being sent, and data is of 5 bytes and length. Okay, so it is also once again sharing like in this way. Okay, so in this way we can send and receive data. So that's it, I guess. These kind of things I have learned from Scapy for now. We can also explore more things, like I can give much complex problem. It will be not that complex, but like we want some unique data to be transferred from one packet to another. So for that I can write range, once again say I want to receive 5 packets, and giving the details of A is equals to, yeah, I can give two layers of IP addresses like src equivalent to F, so that we can receive packet from different addresses. Okay, okay, we are actually receiving more data, so I will stop this and will further continue with this 127.0.0 dot um, I plus 3 this time. Okay, something different this time, and once again closing the parenthesis, and once again I'm giving the IP layer, creating an IP layer, and source equivalent to what will be the source, and source will be, once again let us check whether it will work or not. Point one point, uh, let me open this one. Okay, I plus 3, I'm giving similar for the for trying it for the first time. And then what must be the protocol for transferring the data? I am once again choosing ICMP, which was Internet Control Message Protocol, and then transferring the data, which is also unique this time. So F low from IP address 127.0.0. We can also give spaces in message. It is just simply a message, we can share it in any way. So I plus 3. Okay, and then a dot send with indentation also. Okay, first of all let's start it once again, continue without saving, and then hit enter. Okay, we receive the data, and we also get echo, I guess. Okay, and all the other details also. Okay, length is same, and the source is also different this time, 0.3, 0.4567, and like from 0.3 we are getting hello from IP address this, and so it is working well. You can see hello from IP address this 0.5, and hello from IP address 127.0.0. Okay, so it is working, and thank you, that's it.